A single gram of diamond battery material generates about 0.17 milliwatts of power. Your smartphone needs thousands of times more than that. So why do people call this the future of energy? Because they are confusing time with energy, and that fundamental misunderstanding changes everything. It's not a battery. It's a transducer. A diamond battery is not a chemical battery. It does not store energy and release it on demand via redox reactions. It is a nuclear battery, more precisely, a Betavoltaic device. It quietly converts radioactive decay into electricity, one electron at a time, 24 hours a day, regardless of whether you are using it or not. Most modern designs leverage carbon-14, a radioactive isotope harvested from irradiated graphite blocks used in aging nuclear reactors. These isotopes undergo beta decay, emitting beta particles, which are essentially high-energy electrons. In a diamond battery, these particles collide with a synthetic diamond semiconductor. As they plow through the crystal lattice, they knock electrons loose, creating electron hole pairs. An internal positive-negative junction, essentially the same architecture as a solar cell, collects these charges to generate an electrical current. The diamond doubles as both the energy converter and the radiation shield. It is elegant, physically safe, and technically fascinating. Here is the first trick that marketing teams never explain. Carbon-14 has a half-life of about 730 years. That number sounds incredible, the ultimate buy once, use forever pitch. But in engineering, half-life is a measure of time, not power. It tells you how long the source lasts, not how much electricity you actually get at the terminal. Let's talk numbers. The kind of numbers that kill startups. The power density of carbon-14 is roughly 0.17 milliwatts per gram. That is not a typo. Milliwatts. To put that in perspective, a standard AA alkaline battery can deliver roughly 1,000 to 2,000 milliwatts of power in short bursts. Now look at the device in your pocket. Your smartphone routinely draws 2 to 6 watts during normal use. That is 2,000 to 6,000 milliwatts. To match that draw with a diamond battery, you would need tens of kilograms of radioactive diamond material. Your sleek smartphone would weigh as much as a checked suitcase and be the size of a microwave oven. This is why no serious engineer ever believed diamond batteries would replace lithium-ion cells in consumer electronics. The math isn't just impossible, it is an insult to the laws of thermodynamics. The reservoir versus the leaky faucet. A conventional lithium-ion battery is an energy reservoir. It stores around 700 joules per gram and can release that energy almost instantly. This ability to supply high current or high amperage is the entire reason modern electronics function at all. We need burstiness. We need a battery that sleeps when the phone is in our pocket and roars to life when we stream high-definition video. Diamond batteries flip that logic on its head. They are not reservoirs, they are leaky faucets. They release energy extremely slowly, but for an extraordinarily long time. You cannot accelerate the decay rate of carbon-14. It is a constant, unchangeable flow. If you don't use the energy the moment it is generated, it is wasted unless you add another battery, such as a supercapacitor, to buffer those flows. So if you want a phone powered by diamonds, you would still need a traditional battery inside to store the energy. At that point, why bother with the nuclear diamond at all? Why do we use them? The hierarchy of needs. If the performance is so weak, why bother? Because in engineering, there is a hierarchy of needs. For a smartphone, power output is king. But imagine a pacemaker inside a human chest. Today's pacemaker batteries last about 8 to 10 years. When they die, the patient needs surgery. Surgery means cost risk of hospital-acquired infections and physical trauma. In that chest, you don't need watts. You need microwatts. You need a tiny, reliable electrical pulse that never stops. Suddenly, diamond batteries are not weak anymore. They are perfect. It is a 50-year power source that outlives the patient. The same logic applies to the dark zones of human infrastructure. Under the ocean, at depths of 4,000 meters, there are sensors monitoring tectonic plates. There is no sunlight for solar power, and the extreme pressure makes maintenance a nightmare. Sending a ship to change a battery costs $50,000 per day. In space, once a probe passes Jupiter, solar panels become useless slabs of glass. In these environments, reliability always beats power density. An engineer doesn't want a powerful battery that fails after 5 years. They want a boring one that works for 50. If the use cases are so compelling, why aren't they everywhere? This is the reality of the supply chain. Carbon-14 is not something you mine like lithium. It is a byproduct of nuclear power generation, trapped inside irradiated graphite. Extracting it requires specialized high-security facilities to gasify the graphite, isolate the isotopes to concentrate the carbon-14, and then use chemical vapor deposition to grow a synthetic diamond around it. None of this is cheap. Growing diamonds atom by atom is a massive energy drain. You consume immense grid power to produce a microscopic output. From a green energy perspective, the energy return on investment is abysmal. Furthermore, we face conversion efficiency limits. Only 5% to 15% of the energy from decaying electrons becomes usable electricity. The rest is lost as heat within the lattice. Then there is the legal hurdle. While a carbon-14 cell is safe enough that radiation cannot penetrate your skin, scaling to millions of devices creates a waste stream nightmare. At 700 degrees Celsius in a trash incinerator, diamond oxidizes into carbon dioxide. Instantly, a safe battery becomes a radioactive gas. No insurance company will shoulder that liability. I see diamond batteries as specialized tools, scalpels, not sledgehammers. They do not swell, leak, or age like lithium. Their output is predictable and boring, which is the highest compliment in mission-critical engineering. The real damage comes from hype. When startups market them as universal solutions to inflate stock prices, they destroy scientific credibility. Diamond batteries won't power your world, but they will power the critical sensors that keep your world safe.